Hi guys, this is Construction Technology Unit 1 and it was a couple of years ago, 18th of May 2016. This is the 50 unit paper. I think they got to 60 unit marks now, and it's about an hour, but your paper will be about an hour and a half roughly. But this is a really good piece of revision for you. Oh, don't forget it's for Unit 1 Construction Technology, and it's level 1 and 2, okay? Brilliant. Okay, so first question. Pre-construction activities have to be completed before work can begin on site, and it mentions identify 2 site setup activities. Don't forget you must use before I start a ballpoint pen. And let's go back to the question. 2 site setup activities. Okay, so it can only really be setup is fencing. Wall finish is not appropriate. Temporary lighting, yes. Roofing, definitely not. And foundations, that's easy. This pen's not great, but good job. Name 2 services that may be needed to be protected before work can begin on site. Things that you need to protect, well, electrical and gas. Okay, now I'm doing this very quickly. You may write a sentence in there if you want to. Give the purpose of a slump test. A slump test, as shown here, is to establish the workability of a concrete ratio, okay, and the cement to water ratio with the aggregate and sand. Very important. And the more it falls, the more workable the material is. But it mustn't collapse too much when you've taken it out of the cone. That cone would have been the other way around. It would have been filled up with the wet concrete, or even mortar in some cases, depending on what you're testing. And the amount it drops from the top of the cone gives you a ratio, and that ratio gives you an idea of how workable the concrete is. And it mustn't be mustn't drop too much, because it means the concrete has too much water in it and potentially is therefore weakened by too much water. So concrete slump test purpose, to establish workability. Okay, the compressive test of concrete, the purpose of it to establish compressive. Oh, my pen's gone. Compressive strength. Okay. Yeah, I mean, the compressive test of concrete to establish a compressive strength. Yeah, I think that would be something like that. I think. Hard on that one. Identify 2 methods of stress grading structural timber, machine grading, and compressive. Yeah, okay, stress grading timber. You can actually visually see how a timber is. If it's got too many knots in it, obviously that shows weakness, but these are the most appropriate ones. I'm a bit unsure about that answer, but compressive is about the crushing testing strength of concrete. So yeah, it's the compressive strength. I think that is the right one. Identify 2 types of thermal insulation: glass fibre and foam. That's the common ones that you see. Nothing to do with soffits, nothing to do with flashings or tar battens. Okay, brilliant. Okay, question 4. Identify 2 types of external wall finish. External wall finish would be, in this case, rendering and facing brickwork. Wall plates, nothing to do with it. Chipboard and mineral wool, nothing to do with it. So that's useful. Name 2 types of internal wall partition. Internal wall, so you've got timber stud, And you can have metal stud. I'm going to put that in. Metal stud work. And you can have light weight concrete block. Okay. The internal walls are not normally load bearing, so the partitions can be. They're load bearing. This would be. It could even be concrete. It could even be brickwork, and a heavier concrete block. But these are usually what I think that's what it's really referring to. Name 2 types of internal floor finish: tiles, chip board. Those are some. I mean, carpet isn't really a finish, but you could say tiles possibly and carpet on top. You could, I suppose, you could even use laminate. Okay, right. Number 6. The diagram shows a section through a flat roof at Eaves. Eaves here, the edge. Label 4 parts of the flat roof shown below. This is I've tried to find this in a lot of textbooks, and they're not. It's not commonly shown, but this is the feathering. That allows the angle, the slight slope of the roof, so the water runoff is about 2 or 3 degrees. Okay, insulation between the joists, and that must be insulation. So the joists run in that direction, sitting on the blockwork wall there, but in between the joists it's got the insulation. Breathable membrane, looks like there, the dot dash breathable membrane, and this will be, looks like the felt deck, felt layer. I think that's what it is. Good. Shows the blockwork there, the insulation in the cavity closer here. Doesn't show a wall plate. There'll be a wall plate that the joists sit on, and then you've got, of course, the soffit support, fascia, and then you'll have a membrane here, guttering, of course, and then a down piece here for the felt, which sits on this section of wood here. Okay, it's like a mini fascia almost. Right. Cross sections for a strip foundation. Right, let's just have a look at strip foundations quickly in our textbook. Now, it's important we get this right, and the reason I'm showing you this. Oh dear, Unit 1, can't find it, chaps and chapesses. Strip foundation. Right, where's it gone? Where's my strip foundation? Here we go. Strip foundation is that. Okay, there. So you can stop the video at that point and just remember that. Okay. There's a deep strip foundation. Can you get that? So strip foundation, deep strip foundation, raft, and a pile. So I'm going to move that book there. This is the BTEC Level 2 book, textbook. Very good. And that's page 22. So have a look at those. Okay. Stop the video there and revise those. And know that you've got the brickwork cavity fill. Cavity fill is below ground level and usually up to about 100 mil into the cavity before it gets to the damp-proof course there. Before it gets to the damp-proof course. But they all must have a damp-proof course. Usually 150 millimeters high. There, from the ground. And it stops the splashback of the water and then the water travelling up the wall. Okay, and then of course in this one, which shows a solid solid floor, it shows the membrane under the floor and the insulation, and then the concrete on top forming the floor. Okay, and the raft. Good thing about the raft, it forms the floor at the same time, doesn't it? There we go. Insulation coming down, it should stop, I'd imagine. The insulation really, ideally, should stop just before the DPC, but anyway. And then the cavity fill is below that. Okay. Right. There's your brick, beam and block here, sorry. Right, brilliant. I hope that's helpful for that question. Explain 2 advantages and 2 of eco joists. Eco joists, they use sustainable timber. Explain 2 advantages of using eco joists instead of using solid. They can be much lighter in weight, because you use sustainable timber. It's normally, if you look at it in a section, I'm going to draw a little quick view. You've got 2 pieces of often man-made, or it could even be a solid wood, the ends, and then they're connected with a man-made piece in the middle. If you can imagine a man-made. So there's your 2 sections of wood. Yeah. And then they're connected with this piece in between. And it actually makes the whole thing much lighter. And you can even cut holes in it if you want. And it's better than having, obviously, the equivalent would be an enormous chunk of timber, which is extremely heavy and expensive. Sorry about my sketching, guys, but you can see the advantage of one over another, can't you? Okay, and this could be plywood, made from plywood, this piece here. Yeah, brilliant. Right, okay, give 2 functions of a wall opening. Well, to provide an opening for a door opening. Window. Okay, could be for the pipework running under the wall, perhaps at ground level or just below. Okay. Vertical restraints of a roof is used to resist uplift. That's the pulling up, and it's caused by, let's think, what would cause a roof to be pulled upwards? Well, possibly fire, but I doubt it. Certainly not its self-weight, that would pull it down. Snow, that would pull it down. Wind would pull it up. There you go, wind. Let's go on. Explain 1 reason, this is question 11, 1 reason why a builder is unlikely to use a solid ground floor for a sloping site. Right, solid ground floor, why a builder is unlikely to use a solid ground floor for a house on a sloping, very expensive to start with. So let's look, we've got a sloping site, you're building your house. There's our house. A solid ground floor, well, firstly, you'd have to have an enormous amount of concrete to fill that, to get it level. Plus, you've still got to have your foundations. So you'd have an enormous amount of concrete here, and possibly 2 different levels of foundation. Yeah? So expensive. Okay? Why a builder is unlikely to use solid ground concrete floor for, yeah, so very costly in the use of concrete. Okay, that would be the main reason, I'd imagine. Here's your concrete. You'd have to come right across there to form it. Concrete. Okay, we'll go with that one. Explain 2 advantages of a raft foundation compared to a strip foundation. A raft over a strip. 2 advantages. Okay. Well, there you go. They're the answers. Raft foundation. Advantages. Provides good foundations where solid is variable. Can be used as a floor. Can be used to fit in surfaces like water pipes and gas pipes. Okay. Right. So you've got the answers to those. Explain 1 advantage and 1 disadvantage of using a prefabricated concrete wall construction. Prefabricated. Now I'm going to try and find, if I can, prefabricated, made before installed on site. Okay, so it could be doors, windows, staircases, all those sort of things. Trying to think of something else, but they're the obvious ones. Oh, roof truss. Roof trusses. The advantage: improved quality control, less wastage, okay, on site. Disadvantage: has to be ordered. To eat has to be ordered to exact sizes. You can't add bits on when you get the window in, because you've made the opening too big, or too small, whatever it might be. A disadvantage: can it be more? Let's just think. Advantage of it being a disadvantage of it being pre-made. I can't really think of a disadvantage of being pre-made. You just got to order as necessary. So pre-planning, vital. So that's an extra point. That's an extra point there. But you've got to really know what you're doing on site. You can't have things hanging around. Okay, they get damaged then. Okay, moving on. A developer is planning to build on a new sustainable housing development using green renewable materials and locally supplied. Okay, discuss the advantages and disadvantages of these sustainable methods for housing. Now this is a large question. This is the last one. So let's just do some bullet points, I think, and I'll see if I can help you on this one. I'm trying to look in the book for something about sustainability. Sustainability is all about those products, materials, that when used don't cause long-term damage to the planet or the earth, you know. So discuss the advantages and disadvantages of sustainable methods. Green renewable materials. Well, here's some good points. Green materials. Let's have a think. Materials. And I'm going to put this down. But in your question, you're going to discuss these points. You could use straw. Soft woods. And they're fast growing. That's why. Oh, fast growing. Sorry about that. It's not a T. Fast growing. Okay. Straw bales, yeah. Or thatched. A thatched roof is straw, isn't it? Of course. But you can do straw bales. Or you can. They've even seen straw bricks. Green renewable, softwood, fast growing, from a known source, not just any old woodland. It has to be a controlled source. I'll put that controlled timber. Other renewable materials. Renewable, well, those that can be reused. So I suppose used aluminium can be reused and remelted easily. I think that's a bit of a controversial one because you lose a lot of heat on that one, but it is renewable. You can use it. Hemp, which is another plant-based material. Do some research on this. Plant-based materials. So straw, of course. I'm trying to think of other ones off the top of my head in this book as well. Yeah, I think they seem to be the most obvious ones. I'm thinking. Yeah. I may come back to that question with you, actually. Right. What else? Renewable. I think that covers it quite well. Yeah, I think so. Right. Locally supplied. Well, actually, that's good. If it's locally supplied, less fuel used for deliveries. Okay? Much less fuel used for deliveries. And that's a good thing, isn't it? Okay. What else could be right? You could have larger loads. One load avoid many loads. Okay, if you can do it in one load, good. That's good. Avoid too many loads because you've got more transport costs, of course. Developer. I suppose did a developer's it disadvantage suitable methods for hasn't it? This is quite a complicated question, so I want you to do some little bit of research on this one. I say it's complicated. I think I need to have thought perhaps a bit more detail on this, and I don't want to spend too long on this question with you at the moment. Okay, but think about perhaps things like the carbon footprint. We'll put keywords. Oh, carbon footprint. That's important. Sorry about that. Carbon footprint. That's a really key point. Yeah. I mean, another one for here is cedar. A type of timber. Doesn't rot. Okay. You could even reuse slates. Okay. Okay, you could think about off-site prefab. Fabrication to reduce waste. And put that as a combination. You could actually try and link that in. So perhaps you do use straw bales, but made off-site. Use aluminium, recycled components, even potentially window frames, and argue that, you know, if it's made off-site, it's made from old materials, recycled or renewable materials, it's a good thing. Could be bought. You could buy, yes. You could buy large sections and convert on site. Could be for woods, maybe. Could argue that point. I think that sort of thing is what they're looking for. Okay. I always talk about things like let's discuss advantages and disadvantages of these suitable methods for housing development. Okay. I think that helps. Green materials. Yeah, I think that's pretty good. So something along those lines. Okay. And then if you can extend it into eight good points, which we've got pretty well there, haven't we? Okay. So we've done a very quick whistle stop tour of that paper. I hope you found that useful. Please use your textbook as you go through. Okay. Good luck with the exam.